NVIDIA transitions fully towards open-source GPU kernel modules. Decorative image of light fields in green, purple, and blue. With the R515 driver, NVIDIA released a set of Linux GPU kernel modules in May 2022 as open source with dual GPL and MIT licensing. The initial release targeted data center compute GPUs, with GeForce and Workstation GPUs in an alpha state. At the time, we announced that more robust and fully featured GeForce and Workstation Linux support would follow in subsequent releases, and the NVIDIA open kernel modules would eventually supplant the closed-source driver. NVIDIA GPUs share a common driver architecture and capability set. The same driver for your desktop or laptop runs the world's most advanced AI workloads in the cloud. It's been incredibly important to us that we get it just right. 2 years on, we've achieved equivalent or better application performance with our open-source GPU kernel modules and added substantial new capabilities. Heterogeneous memory management (HMM) support, confidential computing, the coherent memory architectures of our Grace platforms, and more. We're now at a point where transitioning fully to the open-source GPU kernel modules is the right move, and we're making that change in the upcoming R560 driver release. Supported GPUs. Not every GPU is compatible with the open-source GPU kernel modules. For cutting-edge platforms such as NVIDIA Grace Hopper or NVIDIA Blackwell, you must use the open-source GPU kernel modules. The proprietary drivers are unsupported on these platforms. For newer GPUs from the Turing, Ampere, Ada Lovelace, or Hopper architectures, NVIDIA recommends switching to the open-source GPU kernel modules. For older GPUs from the Maxwell, Pascal, or Volta architectures, the open-source GPU kernel modules are not compatible with your platform. Continue to use the NVIDIA proprietary driver. For mixed deployments with older and newer GPUs in the same system, continue to use the proprietary driver. If you are not sure, NVIDIA provides a new detection helper script to help guide you on which driver to pick. For more information, see the Using the Installation Helper Script section later in this post. Installer changes. In general, the default version of the driver installed by all installation methods is switching from the proprietary driver to the open source driver. There are a few specific scenarios that deserve special attention. Using package managers with the CUDA meta package. When you are installing CUDA toolkit using a package manager, not the .run file, installation meta packages exist and are commonly used. By installing a top-level CUDA package, you install a combination of CUDA toolkit and the associated driver release. For example, by installing CUDA during the CUDA 12.5 release timeframe, you get the proprietary NVIDIA driver 555 along with CUDA toolkit 12.5. If you install CUDA or the NVIDIA drivers using the .run file, the installer queries your hardware and automatically installs the best fit driver for your system. UI toggles are also available to select between the proprietary driver and the open source driver as you choose. Hashtag sh/CUDA_12.6.0_560.22_Linux.run. Override. Kernel module type equals proprietary. Hashtag sh/NVIDIA Linux x86_64-560.run. Kernel module type equals proprietary. Using the installation helper script. As mentioned earlier, if you're unsure which driver to pick for the GPUs in your system, NVIDIA created a helper script to guide you through the selection process. To use it, first install the NVIDIA Driver Assistant package with your package manager, then run the script. $NVIDIA Driver Assistant. Package manager details. For a consistent experience, NVIDIA recommends that you use package managers to install CUDA toolkit and the drivers. However, the specific details of which package management systems are used by different distributions or how packages are structured can vary depending on your particular distribution. This section outlines the specific details, caveats, or migration steps needed for various platforms. apt, Ubuntu, and Debian-based distributions. Run the following command. $sudo apt-get install NVIDIA open. To upgrade using the CUDA meta package on Ubuntu 20.04, first switch to open kernel modules. $sudo apt-get install the NVIDIA kernel source open. $sudo apt-get install NVIDIA open. DNF, Red Hat Enterprise Linux, Fedora, Kylin, Amazon Linux, or Rocky Linux. Run the following command. $sudo DNF module install NVIDIA driver. Open DKMS. To upgrade using the CUDA meta package on DNF-based distros, module streams must be disabled. $echo module_hotfixes equals 1 t a/etc/yum repos d/CUDA start repo. $sudo DNF install. Allow racing NVIDIA open. $sudo DNF module reset NVIDIA driver. Zipper, SUSE Linux Enterprise Server or OpenSUSE. Run one of the following commands. Hashtag default kernel flavor. $sudo zipper install NVIDIA open. Hashtag Azure kernel flavor. /15/x86_64. $sudo zipper install NVIDIA open Azure. Hashtag 64KB kernel flavor. /15/SA required for Grace Hopper. $sudo zipper install NVIDIA open 64K. Windows Subsystem for Linux. Windows Subsystem for Linux, WSL, uses the NVIDIA kernel driver from the host Windows operating system. You shouldn't install any driver into this platform specifically. If you are using WSL, no change or action is required. CUDA toolkit. The installation of CUDA toolkit remains unchanged through package managers. Run the following command. $sudo apt-get /DNF/zipper install CUDA toolkit. Please subscribe Cyber Jim Rachel.